Hello, welcome back. Today we're going to be making tables for functions, and you're going to be graphing functions from those tables. By the end of this video, you should be able to make a table for a function and make a graph of a function given its rule and its domain. To make a table for a function and then identify the range. So the function we're given is y equals 2x minus 5. That's for the function part. Notice y is a function of x because y is by itself. And our domain is -1, 0, 1, and 2. So we need to fill out this table so we can find the range. Well, you'll remember domain stands for the x values or the inputs. So our inputs are -1, 0, 1, and 2. I've added a row in between the x and the y that typically is not there to help us go ahead and find the y values. Notice, y is equal to 2 times whatever x is minus 5. So if x is -1, y is equal to 2 times -1 minus 5. 2 times -1 is -2 minus 5. -2 minus 5 is -7. So if x is -1, y is -7. Next one, if x is 0, y is 2 times 0 minus 5. 2 times 0 is 0 minus 5 is -5. So our y is -5 if x is 0. What happens if x is 1? It's 2 times 1 minus 5. 2 times 1 is 2, minus 5 is -3. If when you're filling out these tables you notice a pattern on the y's, because the x's are following the same pattern on top, x goes up by 1, so the y's are going up by 2, we can actually skip finding the process to find the y by just adding 2, -1. Or you can go and fill it out. 2 times 2 minus 5. 2 times 2 is 4, minus 5 is -1. So if x is 2, y is -1. Our range are our y values, -7, -5, -3, and -1. Go ahead and try to make out this table on your own and press play when you're ready to see the answer. Okay, hopefully you filled in the x values as your domain, -4, -2, 0, and 2. To find the range, you would have put these x values in to find the y. By the way, y is equal to 1/2 x plus 1. So 1/2 of -4 plus 1. 1/2 of -4 is -2, plus 1 is -1. Next example, 1/2 of -2 plus 1. 1/2 of -2 is -1 plus 1 is 0. And our third one, 1/2 of 0 plus 1. 1/2 of 0 is 0 plus 1 is 1. You could see the pattern at this point, or you can go ahead and fill it out. Notice we're going up by 1 every single time. If x is 2, y is 1/2 of 2 plus 1. 1/2 of 2 is 1, plus 1 is 2. So our range is -1, 0, 1, and 2. As is usual, we have some vocabulary words. The first one is the Cartesian coordinate system. The Cartesian coordinate system consists of 2 number lines drawn at right angles to one another, and each number line is called an axis. Down below we have an example of a Cartesian coordinate system. Notice the number line that goes from left to right is called the x number line. It goes from negative on the left to positive on the right. The number line that goes up and down is called the y-axis, and it goes from negative on bottom to positive on top. Each of these number lines is called an axis, the bottom one being called the x-axis, and the one going up and down being called the y-axis. Our next vocabulary word is an ordered pair. An ordered pair is a pair of numbers written in a specific order, x, y, and they're inside parentheses. Or you could call it input, output, Again, they're enclosed within parentheses. What you need to know about ordered pairs is that you can transfer them from a table into these things again called ordered pairs. Let's take a look. As an ordered pair, -1, -5 would be written -1, -5. 0, -3 would be written as 0, -3. 1, -1 would be written as, well, 1, -1. And 2, 1, 2, 1. So they're almost identical to a table. You have your x's on the left and your y's on your right, or your inputs then your outputs. The difference is that we enclose them in parentheses and we put a comma between the two numbers to separate them. Please note the parentheses do not indicate any sort of distribution. Let's take a look at our next word, a point on a graph. A point on a graph is an ordered pair that is graphed on the Cartesian coordinate system. So, suppose we were given this function rule, y equals 2x minus 3, and this table, -1, 0, 1, 2, -5, -3, -1, 1. This table came from our function rule. So far we've already made tables from our function rules. Now we're going to be able to transfer that table to a graph. The way we're going to do that is we're going to graph each one of these ordered pairs, -1, -5, 0, -3, 1, -1, and 2, 1. We're going to graph these as points on this graph right here. We're going to go ahead and label our x and our y axis, and we want to label the points x and y to help us keep track of what's what. Taking a look at our first point, -1, -5, the x value is -1, so we move over to -1. Notice I am now one space to the left of 0. Y is -5. So I need to go to where y is -5 and x is -1. So we found x is -1. Let's go to y -5. 1, 2, 3, 4, 5. This is our point, -1, -5, because it is the intersection of where x is -1 and y is -5. Let's try another one. 0, -3. The x value is going to be 0. So this is -2, -1, 0. So x is right here. Y is -3. So we go down. 1, 2, 3. And here we have 0, -3. Let's try 1, -1. 1, -1. Notice the x value is 1 and the y value is -1. And we plotted the point at the intersection of those two. What about 2, 1? 2, 1. X is 2, y is 1. And here we've plotted our function given our inputs and outputs. We're given the function rule y equals 3x plus 1, and we're given its domain. It's a good idea to go and make yourself a table, x, y, and if you like the way it was done previously, you can also make yourself a process column in the middle, splitting it apart like this. It's just a neat way to keep track of your work. So I'm going to go ahead and copy down my x's, -2, -1, 0, and 1. If x is -2, we get 3 times -2 plus 1. If x is -1, we get 3 times -1 plus 1. 0, 3 times 0 plus 1, and 1, 3 times 1 plus 1. The y value is 3 times -2 is -6, plus 1 is -5. The next one, -3 plus 1 is -2, +1, and 4. So that's kind of messy. We can go ahead and rewrite those as ordered pairs, -2, -5, -1, -2, 0, 1, and 1, 4. And then all we have to do is plot them. -2 being the x value, -5 being the y value. So we go -2 on our x-axis, and we go up, or sorry, rather down to -5 on our y-axis, and there's that point. -2, -5. You do not have to label the points unless I ask you to. All it asks you to do is graph the function, so all you really have to do is plot the points. I'm going to go ahead and label them to help you keep track of where the points are that I'm putting. If x is -1, -2, so we go -1 on the x-axis and -2 on the y. Notice, I always do x first and then y. Always input, then output. Okay, 0, then 1, and 1, then 4. You go ahead and watch this example if you need another example worked out for you, or you can pause it and work it out on your own. Either way, there'll be one more example for you to work after this. Okay, I'm going to go ahead and start the same way as I did last time. I'm going to make an XY table. And I'm going to put a process column in the middle to help me neatly keep track of my work. So let's copy down our domain, -6, -4, -2, and 0. If x is -6, we get 2 minus 1/2 times -6. -4, 2 minus 1/2 times -4, 2 minus 1/2 times -2, and 2 minus 1/2 times 0. Again, I'm just copying down my function rule, putting in the x numbers for the x, straight down the line. Finding the y values for this one's going to be a little bit more tricky than the other one, because every time, notice we have a minus 1/2 times a negative number. It's going to make it plus a positive. Minus number times a negative number is going to end up with positives. Minus a number times a negative number end up with positives. And the last one, there's just one negative, so it will not turn into a positive. I went ahead and turned all those to positives to begin with because it's going to help me do a little less thinking as I'm working out through the problem. Okay, 2 plus 1/2 of 6. 2 plus half of 6. Half of 6 is 3, so 2 plus 3 is 5. 2 plus half of 4, that's 2 plus 2, which is 4. 2 plus half of 2, that's 2 plus 1, which is 3. And 2 minus half of 0. Half of 0 is still nothing, so we get just a 2. You go and write the ordered pairs if you'd like, or if you can read through this jumbled mess, we can go and plot each one separately straight from the table. Notice x is -5 and y is 5. Sorry, x is -6. So we'd go -1, 2, 3, 4, 5, 6, and y being 5 would be up here, a little off the graph. Okay, -4, 4. X is -4, y is 4. -2, 3. And 0, 2. And there you go. You've graphed the function given its domain. Alright, go ahead and try this one out on your own and press play when you're ready to see the answer. I will not work this one out for you, but you will see the work done when you press play. Alright, here's your function graphed for you. Notice I've labeled the points so you can keep track of which point was which as I went down. Made one little mistake right here. That should have been 3, -3. As you were working through it, you might have noticed the x's were going up by 1 every single time, and the y's were going down by 2. Anytime you notice there's a pattern with the x and the y, you can go ahead and skip some work and just keep on following the same pattern for the y.